So good morning, everyone, and welcome to the second of our online events today as part of Hammersmith and Fulham Climate Carnival. So today we are running a whole themed day around homes, buildings and energy, and really excited to share this local case study of Hartop and Lannoy Point with you from the fantastic team behind it. So just a wee bit of background, why are we here? I'm sure it's hard to keep away from the news at the moment and hear all of the build up to the UN Climate Change Conference, COP26, which is being held in Glasgow from the 1st to the 12th of November. So world leaders are coming together to decide what we are going to do to respond to the climate and ecological emergency. But in Hammersmith and Fulham, we know that, that's a global context of world leaders, but actually the action and the response to this really needs to work on a local level and be designed in partnership with the community. So today we are having a whole week of events and activities to help everyone take climate action, to show some of the brilliant things that are already happening and help us all learn together. So please do have a look at our program. We've got over 50 events happening this week, both online and offline. And we have just published our Hammersmith and Fulham 2030 climate strategy. And this sets out the route to net zero emissions across homes, buildings and energy. So if you joined our session this morning, you'll know that homes and buildings account for 75% of emissions across the borough. This is one of the biggest challenges that we're going to have to tackle to get to net zero. We're also running breakfast briefings tomorrow and Wednesday about transport and the things we use. So how can we decarbonize the way that we move around and reduce emissions from the things that we buy and use? Our climate strategy also sets out how we're going to protect people and nature, making more space for nature and enhancing biodiversity in the borough, and also preparing for some of those changes that are already underway, from hotter summers to an increased flood risk. And it talks about the way that will enable that, from engaging our community, from showcasing the benefits of the green economy, and making sure that all of our decisions and all of our financial decisions are supporting net zero as well. Okay, so now I am delighted to hand over to Peter, who will introduce the team and the case study as well.
Thanks, Emily. Really glad we can be part of this week's the Council's Climate Carnival in readiness for the COP26 that's happening. Just want to go through today and introduce you to through colleagues of ours, which will be presenting today. I'll give a quick overview of our strategic objectives. But today we've got some sustainability consultants that will talk about net zero and Passivhaus methodology. We've also got Jerry here today to talk about how we're incorporating in our Defend Council Homes policy and co-production into the process, which is vitally important. And we've also got Neil Campbell, which will talk about how that influences architecturally and emerging design. Okay, next slide, Emily, please. So just wanted to give you a very brief overview of Hammersmith and Fulham strategic ambitions on our direct delivery programme in development. We basically inform our building homes and communities strategy. And what does that mean? That means there's a target to build about 1,800 homes over 10 years, or about 9 years now, of which a big majority of that are truly affordable homes. That feeds into our financial strategy and our housing revenue account 40-year financial plan and the assumptions that are made in that. And what we're here to discuss today is our new climate and ecology strategy and those transitional targets that have been agreed by Council to take forward now over the coming years to meet the climate challenge by 2030. Okay, next slide, please, Emily. So part of that is that the Council has a direct delivery programme, and that's basically set up under 2 affordable housing programmes at the moment, where we get GLA grant support to help us deliver those schemes. We have currently 6 named schemes under the current affordable housing programme, that's 2016 to 23, and we've identified about 16 to 19 potential sites that we're still exploring under the current affordable housing programme. And that means at the moment there's a pipeline of potentially about 1,400 homes of which we currently have about 63% of those as affordable. The local plan only requires 50/50, so we're exceeding that as well. And within that overall programme, there's about 8,500 square metres worth of other communal facilities. And that's to be delivered over the next 5 or 6 years. So it's vitally important we try and embed as much good practice as possible. So I'll hand over to Emily Mansfield, who's part of Calford Seed, and she will tell you a bit more about carbon net zero and Passivhaus. Thank you.
Thank you, Peter. So today I'll quickly go through why we're trying to achieve net zero carbon and the planning policies. So why is it important to target net zero buildings? Well, globally, buildings are responsible for 38% of energy related carbon emissions and 50% of extracted materials. It is estimated that 4 billion people across the world are vulnerable to climate risks, and 91% of people worldwide live in areas with air pollution. Even people living in London are at risk from poor air quality. It is therefore imperative that we strive for sustainable design in our new developments, including both new build and retrofit, to help reduce energy consumption and improve the quality of life. Here we can see how sustainable or green homes can help build towards 9 of the 17 Sustainable Development Goals, which are at the heart of the 2030 Agenda for Sustainable Development. We can also see that net zero carbon buildings provide benefits and values, not only to the client or developer, but also to the end user, the residents. These are also in line with the Sustainable Development Goals. We will discuss how some of these benefits can be achieved in a moment, including healthy and comfortable environments, reduced performance gap, which is where buildings don't quite perform as well as they're designed to, and lower energy bills and fuel poverty. Less fuel poverty. Next slide, please. Sustainability framework. The regional planning policy applicable to London Borough of Hammersmith and Fulham is the London Plan 2021. Policy SI2 of Chapter 9, Sustainable Infrastructure, sets out the carbon dioxide emission reduction targets. It is a requirement that new developments in London achieve net zero carbon for regulated energy use, which is your space heating, hot water, ventilation, lighting, and cooling. Net zero carbon means that any emissions produced will need to be offset by renewable generation, such as wind turbines and solar panels, or measures that remove emissions from the atmosphere, such as trees. In order to meet the net zero carbon target relating to regulated energy only, the energy hierarchy, which is shown here on the right, should be followed. We can see that at the top is the most important stage, be lean, as this is where we can design buildings to use less energy through passive measures. Residential development should achieve a 10% CO2 emission reduction through the be lean stage alone. This is achieved by applying the fabric-first approach, with high levels of insulation in external walls, roofs and floors, and an airtight construction. Other measures include heating controls that prevent the heating from being switched on where it is not required, such as simple room thermostats or 7-day hourly programmers. Heat recovery systems should also be applied to help reduce the demand from the main heating system. We'll have a look at one of these in a moment. Applying these measures not only help reduce carbon dioxide emissions, but also energy use and therefore energy costs. It is therefore common for all new build dwellings to achieve an energy performance certificate rating of B, with the fabric first approach applied, therefore indicating your low energy costs. Be clean of the energy hierarchy looks at supplying energy efficiently. This is achieved by providing a communal heating and hot water system where all dwellings are fed by a centralised plant rather than individual heating systems located in each dwelling. Having a centralised plant also allows for easy maintenance and for easy transition over to more energy efficient plant and connection to a wider district heating network should it become available in the future. So it is future-proofing the building to become more energy efficient as technologies advance. Be green of the energy hierarchy requires developments to use renewable energy. Generating energy on site helps reduce the energy demand from the grid. Solar photovoltaic or solar PV panels generate electricity on site. As we move away from mains gas to electric systems, it becomes important to generate electricity on site to reduce the demand from the grid and also carbon dioxide emissions. It also helps reduce the running costs. After the first 3 steps have been applied, on-site regulated energy use should have been reduced as far as possible and technically and financially feasible. The final stage of the energy hierarchy is therefore offset. This requires any remaining carbon dioxide emissions produced by regulated energy to be made up through financial contribution into local authorities' carbon offset fund, so that measures can be applied off-site to reduce carbon dioxide emissions within the borough elsewhere. Next slide, please. So I've provided a bit of background on the principles, but here we're going to look at Passivhaus principles, which is being applied at the heart of the Llannoy development. This project has applied the Passivhaus principles to reduce the energy use and therefore maximise the potential energy and carbon dioxide emission savings under the B-lean stage of the energy hierarchy. So Passivhaus is a German standard that's been adopted within the UK and is gradually becoming a more common practice within our designs. Passivhaus applies the fabric-first approach to its full extent, significantly reducing the space heating demand, as we can see demonstrated in the graph on the right. A Passivhaus building can have a space heating demand a quarter of that compared to a building constructed to meet the current building regulations, Part L 2013 to be precise. The Passivhaus calculation methodology, also known as the Passivhaus Planning Package, or PHPP, provides a robust analysis of how a building will perform and goes into far greater detail compared to the energy analysis used for building regulations. On-site supervision is typically required to oversee the construction process, making sure that materials and products used within the PHPP calculation, or the Passivhaus assessment, are installed and commissioned to be as energy efficient as possible. Earlier, I mentioned how net zero buildings can reduce the performance gap. Well, a Passivhaus building goes under rigorous auditing process during both design and construction to ensure that the building will perform as designed, therefore reducing the performance gap. Third-party certification is required to demonstrate that targets have been achieved. Next slide, please. Thank you. So I'll now go through some of the Passivhaus key principles. To the right, we have a nice little section that illustrates the key elements of a Passivhaus building. The building envelope is well insulated with a thick layer of insulation going around the whole of the outside. So imagine wrapping the building in a duvet. The well-insulated fabric also helps reduce cold thermal bridging through junctions, such as where your external wall meets your windows, doors, balconies, roofs and floors. So anywhere where you'd have a break in the insulation. This prevents the risk of damp and mould. Windows are generally triple glazed in the Passivhaus building to help reduce heat loss and also control solar gains during the summer months. Here we can see how the windows are set back into the insulation layer, which reduces the cold thermal bridging and also provides some shade into the windows during the summer from the deep reveals above the windows. External shading will also help reduce solar gains during the summer when the sun is higher in the sky, but will be designed to allow sufficient solar gains to enter the building during the winter months to reduce the space heating demand. It is all about achieving the energy balance, balancing your losses against your gains. The construction is also very airtight. If you imagine a standard building constructed to Part L of the building regulations can have an air permeability of 10 meters cubed per hour meter squared under a pressure of 50 pascals. So this is like loads of little holes in the fabric, such as around fittings and fixtures, your windows, your doors, your sockets, bath panels, that cause tiny areas of heat loss through infiltration as air escapes through those little holes in the fabric. However, with all those holes combined, it can be the size of a cash machine. While in a Passivhaus building, all those holes are reduced to the size of a credit card. This reduces heat loss through infiltration and also provides a comfortable internal environment, as there are less drafts experienced close to the external envelope. Finally, as we have this airtight construction, we need to ensure that sufficient fresh air will be provided continuously to achieve good indoor air quality, meeting the healthy environment goal. Therefore, each dwelling is typically provided with mechanical ventilation and heat recovery units, or MVHR, as we can see in the bottom right of the section. We can see there against the wall. This provides a continuous supply of fresh air to the dwelling habitable rooms, like your living rooms and your bedrooms, whilst removing stale warm air from the kitchen, bathrooms and toilets. The MVHR unit also has a high efficiency plate heat exchanger within it that allows the heat from the extracted air to be transferred over to the incoming air. This helps reduce the space heating demand, meaning that the space heating system will not need to be vamped up as much as it would in a building that was designed to be less insulated, leaky, and without MVHR technology or heat recovery technology, thus reducing your energy costs. I'll now pass you over to Jackie to discuss embodied carbon. Thank you.
Thank you, Emily. So I'm going to continue this conversation on achieving net zero as we head towards 2030 and beyond, but focus more on the whole life carbon in our building design. So Emily mentioned earlier about the London Plan Policy SI2, which sets out the carbon dioxide emission reduction targets, but this policy also includes reduction of carbon emissions from embodied carbon. So when we talk about whole life carbon assessments in buildings, we're also talking about the amount of carbon consumed over the entire life of the building. So from planning to designing of the building form and services to construction, which includes the extraction of raw materials, through to the manufacturing and delivery to the building in use, including your management and your end of life or your demolition. So for us to talk about whole life carbon, we must discuss the two elements within this, the operational carbon and the embodied carbon. Traditionally, net zero has been largely understood to apply to buildings' operational energy use. This includes both the regulated energy required to provide the heating and hot water, lighting and ventilation, and in some cases cooling, but also the unregulated energy for cooking and all our plug-in appliances and equipment. Now, what we can see from the series of pie charts at the bottom here is that as the emissions from operational energy, shown in blue, are expected to reduce over time due to better design of building fabric and building services, as well as the reduction of carbon factors and grid decarbonisation, a greater emphasis is placed on reducing embodied carbon, shown in pink, associated with the construction process itself. Next slide, please. So a fuller definition of net zero, therefore, must include embodied emissions from materials sourcing and construction, as well as the maintenance, repair and replacement and eventual demolition. Together, operational and embodied carbon emissions over the building's entire life cycle are known as whole life cycle carbon emissions. And we recognise that any definition of net zero should reflect this complete picture. Now, in terms of comparison, operational energy accounts for 28% of global emissions, with embodied carbon accounting for 11%. So that's a whopping 39% of global emissions from the construction and operating of our buildings alone. Now, whilst operational energy currently accounts for a higher percentage, both together present the life journey of our building in carbon terms. So the Mayor of London has set out some ambitious plans, as we know, for the City of London to be net zero carbon by 2030. So is this achievable? Well, with the current climate emergency and the knowledge that buildings account for 39% of global emissions, we have a responsibility as designers to do our part to make this happen. Whilst there are already stringent standards in place with respect to operational carbon, this project also considered the embodied carbon emissions to present an overall picture of the building we are delivering, as this will provide us with more realistic data and benchmarks to enable us to bridge the performance gap. The whole life carbon assessment introduces a responsibility for the design team to ensure that our building designs and our buildings in use stay on course towards net zero future. Next slide, please. So finally, let's have a look at the circular economy. The construction sector is one of the world's largest waste generators, responsible for almost 50% of global waste. And the circular economy would appear to help a helpful solution to diminish this environmental impact of the industry. The main causes of the construction's environmental impact are found in the consumption of non-renewable resources and the generation of contaminant residues, both of which are increasing at an accelerating rate. Now, the industry has come a long way from the linear model of taking raw materials to make something, using it until we don't want it anymore, and then just throwing it away by introducing recycling and diversion of waste from landfill. But we can and we should be doing a lot more. Decision making about the circular economy can be performed on an operational, a tactical, and also a strategic level by doing what we can in the conservation of finite resources, increasing efficiency in manufacturing and construction, and sourcing of materials sustainably. Also designing to both eliminate and or manage the waste sustainably at the highest value. Designers also need to consider the end of life and think about construction systems that can be easily adapted or have the advantage of allowing for easier deconstruction and reuse of the components to create new buildings in the future. A building that requires reconstruction several times over the course of a century to accommodate changing needs of its occupants will inevitably use far more materials than ones that are designed to be adaptable in the first place. So we're considering the building circularity of this project, and the below graphic represents the material circularity of the project, both in terms of material use and end-of-life handling. Overall, there are several outcomes that we're trying to achieve, including thinking more consistently and comprehensively about the approach to design and carbon reduction within this project, so we can be more instrumental in informing the building design and by encouraging a more durable construction and flexible design for greater building longevity. So I'm now going to pass you over to Jerry Cassidy, who will talk to you about, a bit about planning engagement. Thank you.
Thank you. My name is Jerry Cassidy. I'm a consultant town planner, and I'm very pleased that my Glaswegian accent is finally on trend. And until now, much of the emphasis, as you've heard from national and local planning policy, has been on reducing carbon emissions on the new ways of building. But making places work, or placemaking, is equally key in helping nudging behavioural changes amongst residents, new and existing. Things like low carbon transport options, for example. National planning policy is still playing catch up, especially after the government's recent announcement on its net zero strategy. And part of that journey towards carbon neutral communities is encouraging and engaging with them as local experts. The council, since the start of this year, is operating a really important safeguard called Defend Council Homes policy, and it gives council housing residents in Hammersmith and Fulham greater protection over the future of their homes, and it also ensures that those residents will fully be involved in any proposals to redevelop council homes or indeed the land around them. So part of that operation will be through the forming of resident steering groups. And in this case, with the Hardtop and Lannoy example we're giving, there was a resident steering group, indeed it still is, being formed by both the existing entry estates and indeed previous residents. And so far we've had round about 9, we've still got a few to go, and they've helped to inform, add extra things to a wider engagement strategy, basically telling us how we can engage better with their existing and fellow residents. So that's manifested itself with online and public events, in-person events, community outreaches, going to essentially door knocking, and trying to encourage people to participate in these events. Now, part of this important strand is also this culture of co-production, where the council's own disabled housing strategy is woven in to any design considerations. So far, the resident steering group has had specific topic sessions on the height and massing of the proposed scheme, the parking considerations, on the trees, open spaces, and sustainability. Next slide, please. As a result of all this engagement, there's a few themes that have come through, and some specific changes to the scheme that my colleague Neil will go through in a little minute. For instance, we were told that we had to go back and make more space for trees and tree provision. We had to look at the building lines on the surrounding streets of the proposal and make them more acceptable. We looked at some options on where we would put the public space, and we were told by residents that actually making a consolidated, bigger public space was much more important than fragmented. The existing site at the moment has got challenges on levels and heights, and we were told to work much harder to make that truly accessible over one level through the different site accesses. We also were told that there was generally an agreement that if we had to look for some height, the height should be centrally placed rather than on the surrounding edges of the scheme. And of course, this commitment to co-design and accessibility issues was a strong theme that residents and surrounding residents were keen to ensure that we demonstrated. So I'm going to just hand you over now to Neil, who will take you through the specifics of the scheme itself.
Thank you, Jerry. Hello, everyone. Just to move into the case study itself, I'm going to be talking about Hartop, Illinois, which has been mentioned. It's in the south of the borough in Fulham. The site previously had two 14-storey residential towers, which have now been demolished on health and safety grounds. So the site is now cleared, but it sits within the wider Aintree estate. Next slide, please. The overarching aims for the proposal and our brief really was to provide around 135 high-quality new homes, replacing the existing affordable homes that were lost through the demolition. Aiming for 80 to 90% operational carbon reduction compared to the current baseline standards. On-site renewable technologies to generate electricity, and other sustainable features to benefit the wider community, such as the enhancement of a communal amenity space, as Jerry's mentioned, expanding biodiversity across the site, and sustainable drainage. And but above all, we're aiming for the highest quality, comfortable, low-cost, in-use homes for existing and new residents. And as mentioned, a very, very important part of the brief was a commitment to a co-design approach, which meant that the existing and previous residents were part of the design process and could influence the design direction. Next slide, please. So a little bit more about the context within the existing estate, as I mentioned. And it's in very close proximity to neighbouring properties, and you can see that here. So in white, showing the existing properties. So we have quite traditional streets that surround, along with a part of the Aintree estate there in the foreground. It's a constrained brownfield urban site, as you would expect in much of Hammersmith and indeed London. Has complex levels, existing site features and adjacent homes. All of those things we need to take into consideration when we're thinking about how to develop the design of this project. But it does present the opportunity to stitch back into the existing street pattern and indeed the wider neighbourhood. Next slide, please. So, and a little bit from the around the process. So you've heard from some of our colleagues, particularly sustainability colleagues here. It was really important that was an early part of the design, and that we as a team were formed very, very early in the process, particularly around the sustainability and the mechanical and electrical expertise. And that involvement is probably much earlier than you might imagine, almost before you do anything at all and put pen to paper as we start the conversation around the sustainability kind of vision for the scheme. But also we needed the wider design team to input also at the critical stages. And through that early design process, there's an iterative process of testing options, which are reviewed from the specialist perspectives, particularly around the sustainability team. And then those outputs are then discussed, and we refine to make the best kind of scheme we can here in the balance of all the other competing factors that the site and the context and the community present to us. So there's much more detail taken early, really, in this process. And for example, if you see this image here shows, you can see all the PVs there on the roofs, taking full advantage of the flat roofs. And we needed to understand from a very early stage what the capacity of those PVs might be, so that we could work out and develop the model around considering how much renewable energy that was going to provide for the scheme, to see if that was needed to be balanced or incorporate other measures. And it is part of a bigger kind of wider equation about this overall sustainability of the whole proposal. Next slide, please. So we've talked a little bit about the Passivhaus principles, and that has informed the way we approach this design. And to start with, we have to consider that we want to make the best use of the site itself. And so considering where the buildings are located and the orientation and maximising that orientation is what we do first. We carefully consider the form of the building, and the best forms in terms of Passivhaus are a compact form with a low wall to floor ratio, which basically what we're trying to do is less wall so that you have less wall to lose heat through. And once you settle on the building form, then we concentrate on very high levels of insulation, as Emily mentioned, in the kind of Passivhaus principles, air tightness to keep all the heat in, and designing out cold bridges so that and keeping the overall form simple. But I think the point we wanted to illustrate today was that it's not always possible to have the most ideal form from a kind of sustainability perspective, because particularly in a constrained urban location, so there's a careful balance to be struck here between all these factors in creating the right form and massing. And this goes back to testing the options really thoroughly at the early stages, but designing the right building for its particular setting. And that's about its setting within the existing community as well. And the next slide, please. So just there's a few things and particularities about this project that we wanted to go through just to illustrate some of those kind of that balancing through this process that we've been talking about. Firstly, the impact on neighbours, and there's a particular sensitive location where the site adjoins existing homes, the 2- and 3-storey properties. And initially, through our first massing proposals, we were considering a simple 5-storey building on the other side of the road, with stacking flats and a simple kind of straight facade, which is the best approach from a kind of Passivhaus and organising that from that perspective. But when we went through the consultation process, it was felt that the impact of the new homes on the existing was too great. So we looked at taking a floor off, and in that case, in this option, we tested just going about 4-storey, very simple form, but that in turn had an impact on the overall viability of the scheme. So in this case, we looked at setting the top floor back so that that was less visible from the street, so it had less impact. But we know by doing that we then create an increased potential for cold bridging. So this really goes back to that kind of balance that we need to get right about the context of the community and existing homes that we're working within, balance to getting the right sustainability kind of approach for the overall scheme. And Hammersmith and Fulham have a commitment to a positive engagement process. That's a really important factor in this case. So also you can see here that these are examples of the facades and the facade design, and you can see balconies there within the bays. And that's another really important design element. They need to do quite a few jobs, the balconies. They provide amenity, obviously, for the new homes. They also, if you get them located correctly and in front of perhaps the areas of large glazing that you'd expect in living rooms, they can help mitigate overheating because they naturally form a natural shade. But the other thing is that we have to think about is how they're fixed back to the building. And so we've got a combination here of balconies that are there on the ground so that we don't have to fix them back and have a potentially compromise the building fabric through a cold bridge. But as you move up through the building, there are other types of balconies that do fix back. And it's again the balance that we're trying to strike here between the right design approach, so the right form and feeling and design for the street, with the sustainability kind of angle and balance that we need to strike here. The window strategy is another interesting point, and because there's a need to control the amount of glazing, particularly in relation to the orientation and control overheating, but we also want to maximize daylighting, so that immediately there's a kind of a quandary in there of getting it right. And each facade, and depending on where it looks, really needs a different way of dealing with the type and size of windows to do that. But we also have to make sure that the building looks coherent as an architectural proposal. So we've come up with a strategy of creating zones where windows are located that can have larger or smaller windows, but without compromising the overall elevation approach, to keep a simple building and elevation form that we're after that is appropriate for this location. And the last one to draw out today, and perhaps onto the next slide, please, is the roofscape. As I showed you earlier on, we wanted to maximise the amount of PVs on the roof, so that to maximise the contribution to production of on-site renewable energy. There's also a lot of plant associated with some of the way that we're heating and the buildings here that Emily touched on with the MVHR, etc. So all of that needs to go somewhere, and in this case, we've located it on the top of the building. But what we've done is put that within the building form itself. So what we're very aware is that roofs are very visible, and in some ways they're the fifth elevation, particularly when you're looking at the building at different heights from surroundings. So what we've done is raise parapet height so that we can screen that, so you don't have a lot of clutter on the roof. But whilst at the same time ensuring that we're maximising the amount of on-site renewables that we can have here. So through these kind of examples that I've talked about, you can probably see that we've had a lot of competing design elements so far, but we have found that coming together regularly as a project team, and particularly with our specialisms, testing options and making informed decisions with the client has been the most efficient way forward. And we're partway through that process, and we continue to be challenged by these conversations that we're having. But what we're trying to create here, as I said before, getting the right balance and creating the right building in the right place. So we have got a little short fly through here, which I'll ask my colleague Pat to share the screen if that'd be okay. We might just take a moment to upload that, if you wouldn't mind having a go. And that really just walks around the scheme, and I'll just point out some of the features that I've described. So here we go. We're approaching from the south here, and I should just point out that we're still in a design development process. So what you're seeing here is one of the options that we've tested through the massing and elevation design. So we've still got some way to go, and we're particularly around kind of testing the windows and the orientation. So that's some of the work that's ongoing at the moment with Emily and Jackie and their team. What we're looking into here is the large new open space that was very much an important factor in terms of the co-production and design approach, so maximising that space as far as possible. Previously, there was a very small and difficult to navigate spaces, and what we were trying, our ambition here was to create a really accessible new open space that could be used by the existing residents, the new residents, and the wider community as well. What was also very important in relation to the levels, there were some very, very challenging levels across the site, a whole story level change from one side to the other. But what that large open space does is we can change those levels very gradually, so that the whole space is accessible, as opposed to more difficult acute level changes. What you're looking at here is where our proposal abuts existing traditional streets, if you like. So there are sort of Victorian 2- and 3-story houses on one side, and I talked around a little bit the balcony approach, which you can see there, that setback top floor that you can just glimpse there, and that kind of debate that we had about keeping the form really simple, but in that case we felt that stepping the building back was the right thing to do in this particular case. So we're moving along an existing street, but we have new homes on one side, and these are the new family homes. In this case, the front doors onto the street, and that feeling of a traditional street, albeit this is a contemporary building. And then as we move around here, just in the distance there, in the darker brown, you can see where we're tying back into existing homes that really are very in close proximity. But what we're able to do very positive here from a placemaking perspective is create a street and an overlooking where there wasn't one before. All of these lead into this lovely new open space in the centre of the scheme, which will be the heart for everyone. And we're creating the setting, you know, for our scheme as well as the existing buildings, all now looking into this lovely new scheme, lovely new open space. Underneath here is a sustainable urban drainage measures that you won't be able to see, but controlling the runoff, a increase of ecology and increased tree planting. So that's all part of the kind of wider sustainable ambition that the whole scheme has. Thank you. I think I'm going to hand back over to Emily at this point.
Yeah, thank you very much, Neil. And thank you everyone from BPTW and colleagues talking us through that really interesting case study, both from setting the scene of net zero down to what this can actually look like in practice, and exploring some of those trade-offs and challenges as well, and particularly how you're working alongside residents in co-production to achieve that as well. So I'm going to pause the recording here.
Thanks for that, everyone. So finally, just before we wrap up, what is on today? If you have a look at the programme, which is on lbhf.gov.uk/climate-carnival, you can have a look at some of the events that are happening today. We've usually got a couple of webinars in the afternoon and lots of events happening out and about all over the borough. So please do have a look. We've got over 50 things happening this week. So please do check out the programme and get involved if you have time later today. And finally, just before we wrap up, please do sign up to our newsletter. So this is a monthly newsletter all about climate action taking place across the borough. We talk about what we're doing as a council, things that are happening in the community, things you can get involved in, as well as what we're reading and sharing. So if you head to the climate pages on our website, you can sign up for Climate Connects. And finally, that's us for this morning. So thank you very much, everyone, for coming along, to all of our speakers for presenting and for everyone's questions and comments. That's our generic email address there that comes through to me. So look forward to speaking with you there, and our web address as well. Thanks, everyone, and enjoy the rest of the week.